Hey, hey, how's it going? I saw it light up, but I didn't actually hear it.
Oh, my bad. Yeah, I was gonna say good. I'm going good.
Good? Nice. I'm curious to see if anyone else shows up for it, given that it's the break. Um, the
Are we
agenda,
still are we still doing rates of change?
yeah, I mean, the agenda for this class specifically was to do 17A, intro to diff, the diff by first principles type stuff. We're
Oh yeah.
getting to the stage where there's a lot of crossover of the previous classes. The original
Yeah,
idea was
I feel like chapter 17 just pops his head in every single class these days.
yeah. No, fair enough. I mean, yeah. So chapter 17, it's been a bit, yeah, because it makes its way. It makes its way in class one and class three. Um, the original idea was class one is basically unit one and two stuff. Class two, unit three and four, and class three was the Q&A style stuff. But then it became a mix of both, and so that's why we got a lot of repeats. I don't think there's anyone in here that's actually even like at this stage. And so unless there's any like unless anyone wants to revisit that in particular, I'm pretty happy to just continue on with the exam revision stuff. I don't really have that many people that are in unit one and two, or at least those who are in unit one and two are well and truly ahead of that. So I don't know. What are your thoughts? Do you want to just continue on with the exam stuff? I don't think there's anyone else who would particularly mind.
I'm down for exams.
Sweet. All right, let's do it. Now, that just needs me to remember exactly where we're up to. So it was 2022 exam one. I know that much. Unless I've lied about that and got that wrong. Actually, was it exam one? Shit. Yeah, term three, week nine. It would have been exam one. Yeah, okay. Let's pull that up. I mean, you guys might recognize it. Let's see. Can I spot where we might have left off? Oh no, we did finish it all. Yes, that's right. It was in class three. We finished it off. So it was, yeah, we're in exam two now. Cool. We finished this one. No, we got some of this as well. Then a hidden matrices, so we ignored that. We should be fine to jump in here. I don't think anything else is going to be a prerequisite for this one. So what I'll do is I'll chuck both the exam 2 and the solutions doc in there. And then, yeah, we'll start from the top on F. Increase and decrease in population of rabbits is given by S of t. Find the average rate of change between the first two times when the population of rabbits is at a maximum. So tech active, of course, that's a pretty nasty equation to try and understand otherwise. We'll see how we go. Average rate of change means something very specific. You're essentially doing rise or run. Y2 take Y1 on X2 take X1, specifically between the first two times when the population is at a maxima. One of the first things I'd be doing is definitely getting a picture of what that graph actually looks like. Be a bit of a pain to work with. So one of the ways I typically can get the graph up pretty quickly is menu 4A, at least on this one, for zoom fit. I unfortunately don't have many strategies for the Casio. I can't quite give too much guidance around getting the graph up there, except for the fact that maybe you could analyze the graph itself, like looking at the function 1700 e to the sine something plus 2500. You can basically say, oh yeah, it's a circular function with a mid-level of 2500 and an amplitude of 1700. And the exponential term you can pretty much ignore, at least as far as getting the graph on the screen. Obviously, it does something. You can see how the circular function is decaying over time. The peaks and troughs are starting to diminish. The question is therefore telling us to find the average rate of change from this peak to this peak, right? The first two times when the population is at a maximum. Also correct to one decimal place, so that leaves a lot of opportunity for different ways of solving this. Now we are going with that. Does anyone remember what average rate of change is all about as far as how you would go about solving that? Any ideas on what we would do here?
You just get the two coordinates and do rise over run.
Yeah, precisely. Just get those two coordinates, rise over run.
I've
Perfect.
got the two coordinates, but I don't really know how to like interpret them.
To interpret them, sure. Okay.
I've got this like E looking thing on them, and I don't know what that means.
Oh yeah, okay. So how'd you get the? Oh right. So did you how did you get them? I guess was it the graphing tool?
Yeah, I put the graph into the graphing tool, and then I did six menu six, yeah,
Mm.
which is analyze, and then I did the like maximum between the two bounds where the first two maximums are present.
So
Like,
you got your points.
yeah, my one says like four, like you see how your second point says 4012.
Yeah.
My one says 4.01 E plus 3.
Yeah. Okay. So e plus 3 just means 10 to the power of 3. If you don't really like what's going on there, go to your settings, so menu 9, and display digits, and just like, I don't know, tank out the float as far as you want to take it. I know some people are insane and they'll pick like float 20 or some ridiculous thing. Float 6 seems to do fine.
All right.
Hit that as make default just so you don't lose it when you clear the CAS, and then that should give you what you're looking for there. 6 total digits to work with.
Yep.
But yeah, you get your points and
I've got
hold.
your points.
Yeah, I wonder if this actually has a doesn't seem to. Seeing if it can do like a average rate of change. I guess I can do IDX. Maybe that can do something. Do IDX. This will probably just do it at a point, won't it? Yeah, it's going to do it at a point. Hmm. Anyway, so that's one way of doing it. You can grab a copy of each of these. These are already tattooed. Well, this one's actually a bit close. So you might want to increase the float even further to make sure, it says one decimal place. You want to make sure they're at least at maybe 2. That way, you're not getting any rounding errors. So you probably come in, float 7. That should fix itself up a little bit. Grab a copy of each of those. And you sort of be Control C, Control V across, which is not particularly great, but does the job. If you're not much a fan of copy pasting with the with this, then you could probably do like a derivative approach where, because you're looking for turning points, you just do solving for where derivative equals 0. And you could even like use this to help you restrict your domain. You can be like, okay, cool. I know they're both before x equals 200. So when I solve for my derivative, I'm going to, oops, I got to copy the wrong thing there. When I solve for my derivative, I'm going to limit the domain. Can I click this, please? Yeah, there we go. So you can see this can be a bit fiddly. I don't know if you guys are also finding it a bit a pain to click. And then finally, there we go. Cool. So negative 3.6, we can be fairly happy that that's our answer. To give the other thing, you could then solve for where derivative is equal to 0. So ddx of function 0 x, oh, I guess I should say 0 less than x less than 200, comma x. And then you just sort of refer back to here to be like, okay, I want the 38 and the 198, and that'll make it much easier to copy from here rather than having to try to double click into things. Just another way of getting to the points. Fair enough. If there's no further questions, feel free to have a look at part G. You could probably even give a unit for that, actually. Population of rabbits, so it would be rabbits per this time. I think it was weeks. I think time was defined a while ago. Yeah, all the way back there it was weeks. So you could probably even give a unit on that, and that'd be pretty good. You could do negative 3.6 rabbits per week as the average rate of change. The exam report didn't seem to really care for a unit there. I'll state that much. But that seems a bit inconsistent. Feels like you would give a unit. Hard G is a real interesting one. There's a few interesting ways you could take it, both of which are on the rarer side of having to do things. It's not often they ask you for a maximum of a rate of change, but they have. Rate of change at greatest positive value. Any thoughts on how you would go about that? There's a couple of keywords in there, one being rate of change, and the other basically being the maximum of a thing. These are all related concepts.
Chris, does it have something to do with how, as you like approach turning points, the derivative like approaches to zero?
Yeah, it's got definitely something to do with that, right? Because it's saying we're looking for rate of change at its greatest positive value. So in other words, where is the slope steepest? Because bigger rate of change means bigger, steeper slope. So in a sense, this is saying from t equals 40 onwards, what time gives the greatest slope in the graph? And so yeah, you've noticed that as you get closer to turning points, you actually get less rate of change. It's less steep. We're looking for its most steepest. So we already know, like at these turning points, completely flat, no slope at all. But as we get closer and closer up, we get, oh yeah, as it changes, of course, you're going to have different slopes over time. So to maybe make things a touch easier, we could actually define our cutoff point here, which is actually really close. Oh my god, x equals 40 is right there. Fair enough. Should have seen that coming. 38's right there. So the greatest slope as of the right hand side here, if you were to eyeball it, whereabouts would you put it? Can be an interesting question to ask.
I would say like the first minimum turning point and like the midpoint between the first turning point and the first minimum turning point and then the second maximum turning point.
Yeah, so about where that cursor is.
Yeah.
Yeah, no, that's exactly what you would do. Absolutely. Because it's coming out of being a zero, it's getting steeper, 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 and then slower, slower, slower. It is the case that the greatest slope occurs at the inflection point of a circular function. And so one of the ways you could probably do this is just find the inflection point. Grab that. T equals 156. Your nearest whole number? Yeah, 156. It says give the time in weeks, so yeah, 156 weeks. Now, that kind of requires you to understand a little bit about circular functions and understanding that their steepest spot is going to be at the inflection point. So the other thing you could go about is solving this the exact same way you solve for any max or min, which is derivative equals zero, or at least looking at the derivative. Because if you're looking for the maximum of a thing, maximum slope of a thing, you want to then get an equation for that thing. So to get our slope equation, we would just find the derivative of the function that we have right now. And so we go ahead and get our derivative of h of x. It's a really nasty function, but that's fine because we just got to define it. Put it on its own axes, so we don't have to worry about anything crazy going on. And now what we have is a graph that's going to show us the different slopes at different times. So I'm just going to auto fit it for a bit. I think I had it at like negative 100 to 1,000, something like that. It's slope values, so I don't expect the y's to be particularly crazy, although maybe they are. No, I guess they would actually, right? Because it's going to get closer and closer to zero like this. Zero slope as the thing was asymptoting. And so if once again we put in that x equals 40, greatest positive slope is going to be right there because slope is now on our y-axis. This is a derivative graph. And so if we grab the max of this, that should also give us the 158 that we're looking for, which, oh sorry, 156. That's another way of doing it. Looking at the slope graph and then putting slope on your y-axis. It's probably a bit more easier to spot. It just requires a few more steps. So I guess it all just depends on what your understanding of the deepness of your understanding of circular functions will determine more or less which way you'd go about this. Everyone happy with at least one of those ways of going about it? Happy to explain the other if that's okay. Otherwise, part H. Did I lose my graph? No, no, it's just over here. There's your hint that having the graph would be nice for this. So through observing the graph, you would see that the peaks and troughs are getting like pushed in to each other, compressed vertically. Um, and so over time, the fact that our population approaches a particular value, well, we can kind of see what's going on. The peaks and troughs are getting less and less drastic over time until we get closer and closer to reaching some particular y value. Because remember, we're on the
Is it
y-axis.
gonna be 2500?
2500 is correct. Yeah. Now, it doesn't ask you to explain it, but I'm curious to hear your rationality anyway.
Well, I didn't bother to really zoom out with the graph because I
Hmm.
reset my curve and I lost the graph. So, um, well, there's a Y translation of 2500, right? And
Yeah.
just with previous knowledge, if that wasn't there, then the limit, like, it would be approaching zero.
Yeah.
So, you just add 2500 to zero and you get 2500.
Correct. Yeah. So the essential thing that mattered a lot about this was the exponential term in the equation. As soon as you have any exponential with a negative exponent, um, as time approaches infinity, that term goes to zero. And so as you look at this entire left-hand side, since that's all multiply, you've got a zero and a multiplication. The only thing left is the 2500. Yeah, that's exactly what's going on there. The exponential is dominating, or it's the reason why we're getting a decaying circular function over time. Um, I'm pretty sure this works, so I'm just going to double check. Another dumb way you can sort of do it is literally just punch in h of infinity, and that just sort of does it as well. It's kind of funny. Um, you're just setting time equal to infinite because, well, over time, over infinite time. You can do that with limits as well, although it just takes a lot more button presses. Cool. Okay. Question 3, probability stuff now. Head tail. We're told it's binomial, so that's nice. 5 coin flips. Find probability x equals 5. That should be fairly straightforward, this one. Probability is probably freshest in everyone's mind.
Is it 1 on 32?
1 on 32. In fact, yeah, let me double check. Yes, it certainly is. Cool. couple of ways you could have done it. What'd you do?
Just multiply half of each other by itself 5 times.
Yeah, half to the power of 5 works perfectly fine there. Um, because you got a 50-50 split on the binomial, it turns out you don't really need to go through any of the crazy CAS stuff for binomial. You can just do half to the power of 5, which is, in fact, what I've just done here. The binomial stuff just simplifies into itself. You've got x equals 5, n equals 5, the NCR term disappears, and then 1 minus p and p in the Bernoulli sequence, they're just the same thing, so it condenses down. Sweet. Double I is going to be maybe, it should be different. Yeah. Oh, this is not showing up properly, is it? Why is that? Oh god, now I'm losing it. Yeah, binomial CDF is what you do there. So 0.8125, yeah, 0.8125, correct. That's good. Different CAS are going to have different notation, but the key things there are going to be the n equals 5, p equals 0.5, lower bound of 2, upper bound of 5. That's pretty much it. Nice, well done. Probability x greater than 2, x less than 5, correct has 3 decimal places. That's really awkward that it covers the entire screen. I can usually set it up in a way where if I pull up the answers in the background, it doesn't cover everything when I clear it, when I open it up. Strange. Anyway, I shall avoid opening up the answers ahead of time. Yeah, conditional probability. That's right. So 0.806, 0.806 is good. Yeah. So conditional probability. First thing you'd want to do is, I don't know why there's a typo there, all that space, but yeah. Conditional probability is the intersection of the two things divided by whatever the conditional is. So in this case, conditional, well, in every case, conditional is what's on the right-hand side, which is the x less than 5. From there, you have to now simplify what this intersection is. So greater than or equal to 2 and less than 5, you're going from 2 to 4 in that case, since you're non-inclusive of the 5. Then on the bottom, you can do another CDF there if you like. That's totally fine from 0 to 4 on that. I've done 1 minus x equals 5, I guess just to be cute. Just another way of doing it. Yeah. Oh, right. Yeah. 1 minus x equals 5 because we already had the number. Yeah. That made it slightly faster. We already had 1 over 32. So 1 minus 1 on 32 was slightly faster, I guess. Sweet. All right. If there's any questions, let me know. Otherwise, IV, which I think I might have accidentally given a sneak peek of that, but we'll pretend I didn't. Expected value and standard deviation. Those are key statistics that show up in all the kinds of probability. The thing you got to keep in mind is how do you actually go about solving those? Because it differs depending on which one you have. Root 512 using variance and square rooting it. Yeah, cool, hang on. So that'll be for standard deviation. Did you get an expected value as well? Is that yeah, 2.5. Cool. Let's see. Yep, 2.5. So using the binomial method of solving things. This is also in the formula sheet. It is also tech active, so you get a bound reference as well. Yeah, NP, just know what your N is and what your P is. That gives you expected value. And then standard deviation, as you said, square root of variance. So there's your variance equation, root 512. Nice. Now this is back when I used SD of x instead of the sigma symbol. Both work. Here we go. Triple I was the weird one for this one. Again, it's another transformation, the weird thing. We'll definitely get there. But for now, BI. Fairly chill one. Maybe I can do this instead. I'll pop this up here. Is it still going to be a pain? No, it's not. Cool. Now I can have the answers open and also show the document at the same time. Nice. Mission accomplished. This might seem like a tough one at first because the function seems purely generic. Right, we have almost no information in there. There's still a way you can solve this integral. Or at the very least, I should say, state the value of the integral. Because it's less about solving it, more about just knowing what it's going to be. It's worth pointing out we're now in continuous probability. So we've got to now switch our thinking to the rules around continuous and how or what integrals are related with what integrals have to do with continuous. Is it just one? It is just one. Yeah, that's right. You would have noticed that you've got a domain of 1.5 to 3, and the integral is also from 1.5 to 3. Whenever you fully integrate a continuous probability function, the total area under it should be 1 because area is probability in the context of continuous probability. So without knowing anything about the function, as long as it is a probability density function for continuous, area's got to be 1, and hence the integral is 1. Nice. Well done. If there's anything else to clarify, let me know. Otherwise, double I. Beefy one. 3 marks. 2 known equations. Find ABC. So I guess one thing to consider is three variables or three unknowns. Typically, that's a simultaneous equation type thing where you need to have three equations to solve that. You already got two right in front of you. Technically, you've got three right in front of you.
Wait, Chris, is C just zero there? Like, I think,
Is C zero? It might be. Let me double check. What's your rationality behind it?
so it's a quadratic, and
Mhm.
on a quadratic, if I'm right, C is usually the y-intercept,
Yeah.
and since um everywhere else the function is zero apart from 1.5 and 3, when it crosses the x-axis, it will also be zero.
When it crosses
The
the
function is just
x-axis,
like a flat line apart from that little bit. So then, wouldn't the y-intercept also be at the origin?
the line is. Hang on. Repeat that last bit there.
So since the function, right, it's basically a flat line on, I think, on the x-axis everywhere apart from 1.5 and 3.
Yeah.
Wouldn't the
Hmm.
y just be zero since c is just zero?
Uh. Okay. Can't quite make that establishment. Like, yes, the y-intercept of the entire piecewise is zero. Yeah. But if you're just looking at the quadratic portion of it, just because it's only defined from 1.5 to 3 doesn't mean that if you were to extend that out, the y-intercept of that quadratic
All
would
right,
be
yeah,
would be where it was. It's just that you're only seeing a portion of it, and then you're just forcing it zero everywhere else. Um, so fair point. If the entire thing was a quadratic, and you were told it was zero at the elsewhere, then yeah, that logic tracks. But this is more of a forcing it to be zero rather than the fact that the quadratic would have been zero.
yeah.
But nice idea. This one is a bit closer to your fairly standard approach to solving three unknowns with three equations. You've got equation one here, you've got equation two here. I'm not going to quite give away equation three, but it is technically on the page. Just a bit harder to spot. The other thing, of course, is how you actually write these as equations, because you can't quite just put PR h greater than 2.5 on the CAS. This is going to be rewritten in a way where the CAS can actually understand it. Same with this one. So there's a couple of things you've got to worry about. The other equation that's implied in the question, that's a little bit easier to put directly in the CAS. Anyone making any progress with setting up those equations? Or shall I jump in? Okay, let's do it. So, the three equations. It's going to be this one, it's going to be this one, and it's going to be this integral that equals 1, we were told before. So if we have a look at what I've done here, um, equation, I'll skip straight to the equation. Oh, okay, I've actually done it slightly differently. I didn't quite use the 3 to 1.5 equals 1. I did a I added these up and then subtracted them from 1. That's a bit ridiculous, but whatever. Um, cool. So this statement here, h less than equal to 2 is equal to 0.35. That's this integral. That's equation 1 that we're working with. Reason why is because continuous probabilities are given by integrals, and we're capping it at 1.5 because that's our lower bound of the domain. It's less than or equal to 2, so 2 is the upper bound. Exact same logic for greater than 2.5. That gives us that one, equals 0.25. If you chuck these on the CAS, you're going to get this. The third integral, I don't know why I did it this way. I kind of just looked at what was left over, 2.5 to 2. Geez, what was I even doing there? 2.5 to 2. That's a lot for nothing. You're probably better off just putting 3 and 1.5 in as that third equation instead. Um, what even was my logic here? So 2, all probabilities need to add up to 1. So the thing that's missing in this domain, we've done 2.5 to 3, we've done 1.5 to 2. The thing we haven't done is 2 to 2.5. Yeah, okay. So I saw that we didn't. We had this gap from 2 to 2.5, and this is the thing that adds it up to 1. You can do that. That's a lot of logic when all you really had to do was look at this. So, anyway, system of equations. So, every CAS has got a way of doing it. You guys are all familiar with how to set up your system of equations? It will just be plugging each of these, well, either in integral form or in the expanded form, depending on how you like looking at it. Does anyone need to see that, or is it fair enough how that's all going to work now? Sweet. Okay, that's that one. As far as working, the reason why I expanded these out was to sort of show working. So it would say a statement like, uh, probability that is the same as this, is the same as this. And that'll get you, showing that you're doing something in there. Because the actual math of getting the final answer is one big simultaneous equation. Kind of hard to make that worth 3 marks. So doing some of these little expansions in there shows that you're, I don't know, demonstrating at least some other understanding. But okay, triple O. This one, I mean, it's not necessarily tough. It's just sort of like tricky to wrap your head around exactly what way things should go. It is a 6% pass rate question. Yeah. Which, by the way, 3BI, that was a 38% pass rate. Just knowing that the integral is going to be 1. So, some of these questions aren't necessarily the hardest things and still have quite low pass rates. So it should be, if you're getting these questions relatively right relatively quickly, having a look at the exam report can actually be a nice little confidence booster when you realize that. I mean, I think my favorite one is that the tech free, the first question is still around like at best 60% pass rate. And it's the same question every single time. Diff of some sort. And it's still around like at best 60% pass rate. So if anything's going to give you confidence, I'm sure that might. But anyway, triple I. This one is actually rough. Let's see how we go. Yeah, it's a rough one. Okay, so let's let's try a few things. The first thing that really matters is that we're now flipping what's being discussed. We now have this continuous variable d instead, and instead of the height being the thing we care about, so from 1.5 to 3, you're flipping a coin at h equals 1.5, and it's going as tall as 3. Now what's happening is we're looking at it in the context of the ceiling. So 3 is the ceiling, and now this domain is going to be with respect to distance from ceiling rather than from ground to floor or coin to floor. It's now coin to ceiling. So a big part of what you have to do here is understand how you're going to convert this. How you're going to convert that essentially, and in doing so, that will make it a little bit more obvious how to go about it. So that's the first thing we'll tackle there. If you now have to flip your orientation, what kind of how else can I pitch that? Thinking about a mathematical rule that would describe that. So, you'll be able to sort of do it in your head, but as far as how to actually mathematically describe what's going on there, you're effectively describing that as your new distance is now 3 minus h. So you're starting at 3 and then you're subtracting what h was, and that's going to get you to flip your orientation. There wasn't really a great way for me to explain that, so I kind of had to just give that one there. Because, if you were 1.5 meters above ground, 3 minus 1.5 is now how far you are from the ceiling, which also happens to be 1.5. Well, let's say we max out at 3, right? You flip the coin all the way to 3. 3 meters above ground is the same as 3 minus 3 meters from the ceiling. So you're doing whatever your new distance is 3 minus h. So a big part of what's going on here is being able to do that flip. What is d, what is h? That's what makes it really tough. You can kind of see the next step already there, which is substituting into the function. Should I keep going, or do you want to try and take it from here, subbing that into your function? You might get it once you're in there. It still is a bit tough afterwards, but I think you might be interested in giving it a shot. You have your A, B, and C. And even if you don't actually, it doesn't actually matter. I'll say, that's the other hint. These don't actually end up mattering because you're comparing g of d to f of rd plus s. Things you're looking for, r and s, are irrespective of what the actual function is. You can actually answer what r and s is directly looking at this. That'll be the final hints I give before I show what's going on. So from there, it's just a comparison now. When you sub in your function into what f of h actually is, right, once you've done your rearranging, you can now see, okay, f of h is this, so if g of d is that, then essentially all you're doing is swapping your d around, and you can look and see, okay, the coefficient on the d, that's -1, so that's r. You got a plus s, plus 3, s is 3. It's It's a really wonky little thing going on there. Um, a lot had to happen there. You had to understand how to invert from floor to coin down to ceiling to coin. That's one thing you have to do, and that gives you, well, that helps you get this. You then have to sort of imagine what that looks like as an equation. Then you've got to figure out how to actually sub that into my function. And in that way, because you've got f of h as a thing, the original function is f of h, the only way you can put d into it is if you start by replacing the h. So you've got to actually flip it. Then once you flip it, you've now got to understand, oh, I've got something that looks like this, I've got something that looks like this. I can now compare the coefficients. A lot going on. It was a separator question. You can imagine why it was only, what was it, 6% I said? That's actually quite high, all things considered. And even stranger still, some people said R equals 1 and S equals 3, which imagine doing that. Imagine going through all that effort and you just put in the wrong number right at the end. That would have sucked. So that had a significantly higher pass rate than I would expect. There's a lot going on there. Is there anything left to clarify around what's going on there? I know it's definitely tough. A lot. Okay. Let's see how much else we can smash out in the remaining 5 minutes or so. But yeah, can we do any more? Yeah, question 4 is coming up. Let's see if we can quickfire a few of these. Mika sister Bella has a coin. Probability of P for success, 1 minus P for fail, or head and tail. P is something between 0 and 1. 25 times is our number of flips. P hat, so that tells us it's sampling and estimation. Specifically for heads. First things first, is P hat discrete or continuous? I'm hoping this is a really easy answer. Yeah, discrete. P hat can never be continuous. Just simply based on the fact that you have to have an n in there. Yeah, easy. Justify the answer. I mean, you got a million ways of justifying that. It's discrete because you can only have head or tail. You can't have anything in between. Yeah, that'll do. P hat is 0.4. Find an approximate 95% confidence interval. This is more or less just a plug directly into the CAS. So you've got a CAS function that does this, although if you are going to use the CAS function that does this, you do need to convert a little bit of what p hat is. So if we go, it's in the statistics menu, statistics, confidence intervals, 1 prop z interval. Now, 95% confidence interval, that's fine, that's your C level. Difference is this has got X as successes and N for trials. So we just got to sort of figure out how we're going to put X and N information in here. One of those is immediately able to be put in there. The other takes a bit more effort. And it's 25. Yep, that's nice and easy. That came from the question. X is a little bit harder. Got to put in a bit more effort for it. Got to do with p hat. Think about how p hat is calculated if you were to try and calculate a p hat. it's worth pointing out p hat is always going to be x on n. So it's the number of successes you have divided by the number of trials. P hat always x on n. So if p hat is x on n and p hat is 0.4, then you essentially have an equation that's just 0.4 equals x on n. X is equal to 0.4 times n. So if you're already in this window, that's fine. You just do 0.4 times n. Then I'll give you nastiness, so just control enter it. C lower and C upper are your lower and upper bound, respectively. In my notes, I give the actual equation that you get on the formula sheet. Yeah, I mean, totally fine to do that as well. Just bashing both of those out on the CAS, there's really nothing else to talk about for that. You do need to know z equals 1.96 for it, but obviously being bound reference, you can just sort of have that in there. So yeah. 0.02, yeah. Sorry, 0.20, and then 0.59, 0.59. Yeah, those are both looking good. And then lastly, this is one that comes up a couple of times actually. We've seen this before, which is here's a bunch of information about a confidence interval. What do we have to do to n to have some effect on the width of a confidence interval? We've done a question very similar to this before in one of the more recent exams. Basic rule is for a factor of 2 decrease, you want a factor of 4 increase on n. The way to mathematically prove that is to define your width, which is defining. In fact, I've done it a little bit differently here now, haven't I? Effectively, you're defining your width and then seeing, okay, what would it take to halve the width? So we halve it, then do some math, and then try to put the factor on n. It's kind of the reverse way of going about it. Most questions will have you will already increase n and then tell you what to, then ask you to figure out what the width thing will be. This time we already had the width thing, and then we had to do some root math to put the factor on the n. Anything else to clarify there? If not, that's about it for the class. I'll leave you to enjoy the rest of your day. No worries.